Today we're going to do u-substitution again, and in this video we're going to do two examples where we have to do something that I call back substitution. You will see that in some places in some notes, but not everybody calls it that. So, but this is really just a fancy type of u-substitution that will work sometimes. We'll do only a few examples with these. We'll do 2 examples in the video and 2 in the notes. So this isn't something that we use all the time, but it's useful to know. So let's get started. So I have this example here. This doesn't look like an obvious u-substitution, but it's definitely not something we can do otherwise unless we want to multiply out x minus 1 to the 5th, which I don't want to do. So our best guess for our u would be the thing that's inside of another function, so the x minus 1. So if u is x minus 1, its derivative is just 1, which tells us that dx has to be equal to du. You're going to notice we're going to have a little bit of a problem when we try and rewrite this integral, but let's try it. So the x plus 3, we don't really know what to do with yet. Then we have u to the 5th du. And now I have to figure out what to do with that x plus 3. We don't want any x's left behind when we do our u substitution. So how do I write x plus 3 in terms of u? Think about it. So we know that our u is x minus 1. So if we solve that, for x, I get x is u plus 1, so I can make that substitution. So we'll have u plus 1 plus 3 times u to the 5th du. And so this is u plus 4 times u to the 5th du. Before I anti-differentiate, I need to multiply things through. So this is u to the 6th plus 4u to the 5th du. That's something I can anti-differentiate, so let's do it. So I'm going to get 1/7 u to the 7th plus 4/6 u to the 6th plus c. So c. And so now I can substitute my u back in. This is the point in time where these problems look really messy because the answers are not going to be pretty when I plug x plus 1 in for my u, or x minus 1. So 4/6 is 2/3, x minus 1 to the 6th plus c. Okay. So let's think about why that method is called back substitution. And it's called back substitution because we're doing this piece here where we solve for x and then substitute that back in. So that's where kind of the term back substitution comes in. So I'm just going to record this all in one video. Why don't you try this next example on your own and then restart the video. So if I try a u substitution here, I definitely want to choose the x squared plus 1 to be my u, so my du over dx is 2x. This one's going to behave a little differently than the first one did, but that's fine. And so this tells me my dx is du over 2x. And so if I replace things, we don't know what to do with the x cubed yet. That's okay. We have root u to du over 2x. So if I simplify things a little bit, I'm going to pull this 2 out front as a 1/2. This x will cancel out with one of these, leaving us with an x squared over root u du. We still have the problem of that x squared being in here, but just like the last time, we noticed that our u is x squared plus 1, so I can easily solve that for x squared. So x squared is u minus 1. And so if I make that substitution, that's our back substitution here. I have u minus 1 over root u du. We have to simplify this before we anti-differentiate, which is oftentimes something we'll have to do in these types of problems. So I'll have 1/2 u over root u minus 1 over root u du. So this is 1/2. The integral u to the first over u to the 1/2 is u to the 1/2 minus u to the negative 1/2 du. So if I anti-differentiate that, be careful that that 1/2 is out in front of everything. So maybe I'll go ahead and distribute it into the integral before I anti-differentiate, just so that I don't forget about it. So I have 1/2 u to the 3/2, I have to multiply by 2/3, minus u to the 1/2, so I multiply by 2 and I have that 1/2 out front, plus c, so we notice like some of these things cancel out. So we're going to have 1/3. What was my u? X squared plus 1. So x squared plus 1 to the 3/2 minus x squared plus 1 to the 1/2 plus c. I don't think you ever would have guessed that that was the antiderivative of the expression that we started out with, but it is indeed. Once again, you can always check your answers by taking the derivative, but you might have to simplify things in kind of a messy way here to do that. So we'll do 2 more examples of these in class. There are no pre-class problems, so you should be just uploading these notes to show me that you've done some work before class. And if you have questions, we'll do more practice, and we'll just do some practice with general u-substitution in class as well.